Welcome to this explainer. Here's a number that should stop you cold. There are currently over 27 million software developers on the planet. But here's the thing. Companies are not looking for generic developers anymore. They're looking for backend engineers who understand the full stack of modern infrastructure. From how a database actually indexes queries to how a Kubernetes cluster schedules containers. So today we're building the complete backend engineer roadmap for 2026. Not a list of technologies, a mental model. Before we dive into what you need to learn, we have to understand what the role actually looks like in 2026. Because it has fundamentally shifted. 5 years ago, a backend engineer was someone who wrote APIs and connected them to a database. That was the job. Today, to be really clear, you're expected to understand distributed systems, container orchestration, cloud infrastructure, and security architecture, sometimes all at once. The line between backend engineer, DevOps engineer, and system architect has become incredibly blurry. Stack Overflow's 2025 developer survey confirmed this. Backend developers are now the single largest developer population. Over 40% of all professional developers identify as backend or full stack with a backend focus. The demand is enormous, but so is the skills gap. So here's our roadmap. We're covering 4 pillars. Pillar 1. Core foundations. Languages, databases, and the fundamentals you cannot skip. Pillar 2. APIs and communication. How services talk to each other at scale. Pillar 3. Infrastructure and DevOps. Containers, cloud, CI/CD. And Pillar 4. System design. The mental models that separate senior engineers from everyone else. Let's kick things off. Section 1. Core foundations. If you take nothing else from this video, take this. The fundamentals are non-negotiable. You can learn Kubernetes in a weekend. You cannot learn how to reason about data consistency in a weekend. Pillar 1 starts with a language. You need exactly one backend language to go deep on. The data from the 2025 Stack Overflow survey is pretty clear on this. JavaScript, specifically Node.js, is the most used backend language. Roughly 38% of backend developers use it regularly. Python follows at around 32%. Then Go, Java, and Rust in that order. But here's the thing, most roadmaps get wrong. The specific language matters much less than how deeply you know it. A developer who deeply understands concurrency patterns in Go will outperform someone who has surface-level knowledge of 5 languages. Pick one. Go deep. The rest you can pick up as needed. Alongside your language, databases. And I want to be very specific here, because this is where a lot of engineers plateau. You need to understand 2 completely different database paradigms. Relational databases, PostgreSQL or MySQL, and how to design normalized schemas, write efficient queries, and actually read a query execution plan. Not just memorize SQL syntax. Actually understand what the database engine is doing under the hood. And then, non-relational databases. MongoDB is the most common entry point, but the real skill is understanding when not to use it. When your data has complex relationships, when you need ACID guarantees, when eventual consistency is not good enough, those judgment calls are what make you a backend engineer, not someone who just writes code that talks to a database. Which brings us to Section 2, APIs and communication. And this is where things start to get really interesting. If Pillar 1 is what you build with, Pillar 2 is how your services actually talk to each other. And in 2026, this is no longer just REST versus GraphQL. The landscape has gotten significantly more complex. The first thing you need to master is REST API design. But I don't mean just knowing what get, post, put, and delete do. I mean understanding proper resource modeling, pagination strategies, versioning approaches, and how to design error responses that actually help the client debug issues. These details are what separate a production API from a tutorial API. Beyond REST, you should understand gRPC. It is rapidly becoming the standard for internal service-to-service communication in high-performance systems. Google, Netflix, Square, they all use gRPC internally because the binary protocol is dramatically faster than JSON over HTTP. If you're building microservices that need to talk to each other at high throughput, gRPC is increasingly the answer. Then there's the async layer, message queues and event-driven architecture. Kafka, RabbitMQ, or cloud-native alternatives like AWS SQS and Google Pub Sub. The core concept to internalize here is decoupling. When Service A needs to notify Service B that something happened, but Service A should absolutely not be blocked waiting for Service B to respond. That's where a message queue enters the picture. This pattern alone solves an enormous number of scaling problems. And finally, the gateway layer. We've actually done a dedicated explainer on API gateways on this channel. If you haven't seen it, it covers exactly how gateways centralize authentication, rate limiting, and routing. Link in the description. Moving into Section 3, Infrastructure and DevOps. And I want to be direct about this. In 2026, infrastructure is no longer optional for backend engineers. It is the job. The entry point here is Docker. If you don't know Docker yet, start today. The ability to package your application with all of its dependencies into a single reproducible container is now table stakes. It's not a nice to have. It's a requirement. The next step up is Kubernetes. And here's where I want to give you a practical tip. Do not try to learn Kubernetes by reading the documentation. It is over 3,000 pages. Instead, learn it by doing. Deploy a simple application to a local cluster using Minikube. Understand pods, services, deployments, and ingress. Those four abstractions cover 80% of what you'll actually interact with day to day. CI/CD is the third piece. GitHub Actions is the most accessible entry point. It's free for public repositories and deeply integrated with the GitHub ecosystem. The concept is simple. Every time you push code, automated pipelines build, test, and deploy your application. The practice takes time to get right. Start with a pipeline that just runs your tests on push. Then layer in staging deployments. Then production. The cloud is the fourth layer. AWS, GCP, or Azure. Pick one. The specific provider matters less than understanding the fundamental cloud primitives. Compute, which is essentially virtual machines or containers. Storage, object storage like S3, networking, VPCs, load balancers, DNS, and managed services, databases, caches, and queues that you don't have to run yourself. Here's a statistic from the 2025 Cloud Native Computing Foundation report. Over 90% of organizations are now running containerized workloads in production. The cloud is not the future, it's the present. And backend engineers who can't navigate it are being left behind. And that brings us to our final pillar, system design. This is the discipline that ties everything together. It is also, honestly, the hardest one to learn because you cannot learn it from a tutorial. System design is fundamentally about trade-offs. There is no perfect architecture. There are only architectures that are appropriate for specific constraints. Your job as a backend engineer is to understand the trade-off space, the core concepts to master in order. Number 1, caching. What to cache, where to cache it, and how to handle cache invalidation. Phil Carlton famously said, there are only two hard problems in computer science: cache invalidation and naming things. He wasn't joking. Number 2, load balancing. Understanding the difference between layer 4 and layer 7 load balancing, and common algorithms like round-robin, least connections, and consistent hashing. Number 3, database scaling. This is a deep topic, but the high-level pattern is start with read replicas, then introduce sharding, and understand the consistency trade-offs you make at each step. The CAP theorem is not just a theoretical curiosity. It is a practical constraint you will hit in production. Number 4, microservices decomposition. How to decide where service boundaries belong. The wrong decomposition creates a distributed monolith, the worst of both worlds. You have all the complexity of microservices with none of the independence benefits. And number 5, reliability patterns. Circuit breakers, retrees with exponential backoff, bulkheads, and graceful degradation. Netflix's Hystrix library popularized these patterns, and they are now fundamental knowledge. If you're preparing for system design interviews specifically, the gold standard resource is the book Designing Data-Intensive Applications by Martin Kleppmann. Read it, then read it again. It will fundamentally change how you think about back-end systems. So, where should you actually start? Because looking at all 4 pillars at once is completely overwhelming. Here's my practical advice. Start with Pillar 1. Pick a language. Node.js or Python are the most accessible. And build a CRUD API that talks to a PostgreSQL database. Get comfortable with that flow. Then layer in Docker. Then deploy it to a cloud provider. Then and only then start exploring message queues and distributed systems. The mistake most people make is trying to learn everything simultaneously. That's how you end up with surface-level knowledge of 15 technologies and deep knowledge of none. The back-end engineers who get hired and promoted are the ones who can go deep on a few things and reason intelligently about the rest. If this roadmap was helpful, I've linked our dedicated explainers on API gateways, JWT authentication, and OAuth 2.0 in the description. They dive deeper into specific topics we touched on here. Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.